Now, acceleration due to gravity. What do you mean by acceleration? Acceleration means change in velocity by time or rate of change of velocity. Rate of change of velocity means change in velocity per second. Change in velocity per second. So, this is acceleration. Now, acceleration due to gravity. When the body is moving along a straight line on the surface of the earth, like this, when the body is moving along a straight line on the surface of the earth, then motion of the body does not influenced by the gravitational force of earth, because earth attracts every body on the surface of the earth. So, this is earth. Earth attracts every body towards its center. So, when the body lies in air, when the body lies like this body is attracted by the earth towards its center like this. So, here when the body is moving downwards from certain height, or when the body is moving upwards like this, then this motion is influenced by the force of the earth, because it attracts every body. Earth attracts every body towards its center. So, towards its center. Hence, when the body is moving either upwards or downwards from the surface of the earth, its motion is influenced by the gravitational force. But whereas, when the body is moving along the straight line on the surface of the earth, its motion is not influenced by the earth. That means, the acceleration produced in the body is not because of the earth. This is because of the other external parameters. Like, for example, when a bus is moving, when driver applies brakes, then velocity of the bus, speed of the bus changes. Similarly, when the driver raises accelerator, then speed of the bus increases. So, in this case, so here the driver applies external force. Because of this force, acceleration is produced in the bus. So, in this way, when the body is moving on the surface of the earth, the acceleration produced in the body is because of the external parameters, external agency, but not because of the gravitational force of earth. But when the body is moving either upwards or downwards, in this case, because of the gravity of earth's force, acceleration is produced in these bodies. Acceleration produced in a body, in a freely falling body, say freely falling body like this. For example, if you take this is earth center. So, this is a body which is just dropped from certain height, just dropped without any initial force, just dropped like this. So, when the body is just dropped from certain height, then its velocity increases gradually because of Earth's force, attractive force. So, Earth's attractive force always acts towards the center of the earth like this. So, because of this force, velocity of this body, freely falling body dropped freely from certain height is called freely falling body. Body dropped from certain height, just dropped from certain height is called freely falling body. So, here the velocity of the freely falling body gradually increases. That means acceleration is produced in this body, because whenever velocity changes, acceleration comes into picture. So, here velocity of the body gradually increases, acceleration is produced in this body. Now, the acceleration produced in a freely falling body is called, in a freely falling body due to gravity of earth, earth's gravity, that means earth's gravitational force, is called acceleration due to gravity, and this acceleration due to gravity is represented by g, small g. So acceleration produced in a freely falling body due to earth's gravity is known as acceleration due to gravity. Now here when the body is moving downwards from this from certain height, or when the body is projected vertically upwards like this, in both the cases acceleration is produced in the body, and that acceleration is called acceleration due to gravity. Now here this acceleration is represented by g, and its value is fixed for a given region of space. For certain small region, this value is constant, and its value is 9.8 meter per second square. What do you mean by this value? For example, this is a body just dropped from certain height. This is the earth surface. When this is dropped from certain height, say some h like this, then initially there is no velocity for this body, that is initial velocity of the body is 0, since it is just dropped without giving any initial velocity, without applying any initial force, just dropped. When this is dropped, immediately earth applies force, attracts that body, because of that its velocity increases. Now acceleration due to gravity is 9.8 meter per second square, means for every 1 second velocity of this body increases by this value. That means at the beginning velocity of this body is 0. After 1 second, suppose if it comes to this point here, its velocity is 9.8 meter per second square, 9.8 meter per second. This is in 1 second. So for 1 second its velocity becomes 9.8 meter per second, and the second, this is second. So after 2 seconds, otherwise after 2 seconds its velocity increases by another 9.8. Already this is 9.8 in 1 second. In the second, at the end of the second, its velocity again increases by another 9.8, means 19.6. It becomes 19, velocity becomes 19.6 meter per second. In this way, in a freely falling body, for every 1 second, velocity of that body increases by 9.8. So this is meaning of acceleration due to gravity. So this is constant. So this is uniform acceleration. So the acceleration due to gravity is constant for a given place. Hence, acceleration produced in a freely falling body, or when a body is projected or thrown like this, thrown vertically upwards. So in both the cases, the acceleration produced is uniform. It remains constant. Hence, acceleration due to gravity is a uniform acceleration produced in freely falling bodies and bodies thrown vertically upwards for small region of space, for smaller heights in general. So this is acceleration due to gravity. So acceleration due to gravity is the acceleration produced in a freely falling body due to Earth's attractive force, which is Earth's gravity, is known as acceleration due to gravity. Okay. Now if you take body projected vertically upwards, so if you take vertically projected body, vertically projected body means body which is thrown like this, body which is thrown with certain velocity, say some u, body thrown with a certain initial velocity u from the surface of the earth vertically upwards is called vertically projected body. In this case, what happens when the body is thrown like this? Earth attracts towards its center. Earth attracts that body towards its center. Because of this force, the velocity of this body gradually decreases and finally becomes 0 at a certain height. After that, what happens? Again, it comes down towards the surface of the earth. So this is the situation. So when the body is thrown with a certain initial velocity vertically upwards, because of the gravity, its velocity gradually decreases and finally becomes 0. That means here velocity changes. Since velocity changes, acceleration is produced, and this acceleration is called acceleration due to gravity. So here in this case, acceleration is equal to acceleration due to gravity. Moreover, since velocity decreases, the acceleration is negative. Hence, A is equal to minus g. Acceleration produced is fixed, that is g. But here, since as the body moves like this, since velocity decreases, acceleration is negative. Hence, for body projected vertically upwards, in that case, acceleration is taken as minus g. So this is an important point. So when the body is thrown vertically upwards with a certain initial velocity, the acceleration produced in this body is negative and its value is g. So A is equal to minus g. So finally what happens at the maximum height? This is called maximum height. That means velocity, as the body is thrown vertically upwards, velocity decreases and finally becomes 0 at a particular height. At this height where the velocity becomes 0 is called maximum height. So this is what is called maximum height. So maximum height is h. So at the maximum height, the final velocity is 0. So for body projected vertically upwards, the parameters are like this. U is equal to u. This is the initial point where it is projected, A. This is the final point where it reaches the maximum height. So initial point, at the initial point, the initial velocity is called initial velocity. So at this point, initial velocity u can be written like this, u. So at the maximum height, that is at the final point, velocity is 0. So final velocity is 0. And since velocity decreases in the upward direction, the acceleration is negative in the upward direction. So A is equal to minus g. So these are the parameters for body projected vertically upwards. Okay. Now in this case, we generally define few things, few parameters. What are those parameters? Here, for this body, it takes some time to reach the maximum height, and that is called time of ascent. So time of ascent. Ascent means upwards. So time of ascent, and this is represented by T subscript A, TA. So what is the time of ascent? Time taken by the body which is projected vertically upwards to reach the maximum height is called time of ascent. So time of ascent is the time taken by the vertically projected body to reach the maximum height from the ground, from the surface of the earth. That is called time of ascent. So you can calculate time of ascent, means you can derive a small expression for the time of ascent. So here in general, body is projected with certain initial velocity. So means initial velocity is given because we are projecting, we are throwing the ball. So we know the initial velocity. So initial velocity can be written like this, u. So in terms of initial velocity, you can get the expression for time of ascent like this. So to get the expression for time of ascent, you consider the data. So body is projected from A with an initial velocity u, then it reaches the point B where its velocity is 0, final velocity is 0. So in this case, the time taken for the body to move from A to B is called time of ascent. So for this journey, initial point, final point, u is equal to u, initial point, initial velocity, u is equal to u. And here, since the body is moving in the upward direction, gravity acts, because of that acceleration becomes negative, and you can write this as a equal to minus g. And t is equal to ta. For this we have to get the expression t equal to ta. Then final velocity, that is at the highest point, velocity is 0. So final velocity is 0. So this is the data for vertically projected body. So using the expression v is equal to u plus at, you can write v as 0, 0 equal to u plus a is equal to minus g. So this is minus g into t is ta. This is ta. So you can write this minus gta, when this is taken towards left hand side, it becomes gta is equal to u. From this you can write ta is equal to time of ascent equal to u divided by g. So this is the expression for time of ascent. So when the body is projected or thrown vertically upwards with an initial velocity u, then time of ascent is equal to u by g. That means here time of ascent depends on initial velocity of projection. Suppose if you are given certain initial velocity, then the time of ascent is 5 seconds. Suppose if the velocity is doubled, then time of ascent also becomes doubled. So initially if it takes 5 seconds to reach the maximum height, when initial velocity is doubled, then time of ascent becomes 10 seconds. In that way, time of ascent depends on initial velocity of a projection. It is directly proportional to initial velocity. So when the velocity is doubled, time of ascent is also doubled. When the velocity is halved, then time of ascent also becomes half. Okay, so this is the relation between time of ascent and initial velocity of projection, directly proportional to initial velocity of projection. Okay, this is one parameter, time of ascent. Then you can get the expression for maximum height. So how the maximum height depends on initial velocity of projection, like that. So for this, again you consider body which is thrown from the surface of the earth with an initial velocity u, then it reaches the maximum height where final velocity is 0. Okay. So if you take this situation from this point to this point, you can write the data like this. So maximum height, so maximum height is represented by capital H. Then what is maximum height? Height of the projected body, vertically projected body, height of the vertically projected body from the ground where its velocity becomes 0. So at the highest point, velocity becomes 0. So maximum height is the height of the vertically projected body at which the velocity of the body becomes 0 is called maximum height. Okay. So to derive the expression for maximum height, we consider the data like this. So initially this is the initial point and this is the final point of the journey. Hence here initial velocity is u, because this is known, we are giving velocity to the body. So we know the initial velocity u equal to u. Then since the body is moving vertically upwards, acceleration is negative, and this acceleration is called acceleration due to gravity, hence a is equal to minus g. Then here displacement traveled or covered by the body is AB. This is nothing but h. So s is equal to h. then final velocity at the highest point is 0. So to derive the expression for maximum height, we consider that data like this. Initial velocity equal to u, a is equal to minus g because the body is moving upwards, velocity decreases, hence acceleration becomes a negative, and its value is a standard value g because that is called acceleration due to gravity. So a equal to minus g, and s is h, displacement covered by the body is nothing but height, maximum height, and at the highest point final velocity is 0. Then which expression can be used, which equation, kinematic equation can be used for this? Yes, v square minus u square equal to 2as. You can use this formula. So 0 square minus u square is equal to 2 into minus g into h. Or you can write minus u square equal to minus 2gh. Minus minus cancels out. So h is equal to u square by 2g. So this is the expression for maximum height. H is equal to u square by 2g. So maximum height depends on, again, initial velocity of projection and directly proportional to square of initial velocity. So h is equal to u square by 2g. Of course, here g is constant. So when u varies, maximum height also varies. When u becomes doubled, then h becomes 4 times because here u square, h is proportional to u square, and when u becomes 2u, then h becomes 2u whole square, that is 2 square into u square. 2 square means 4. So when initial velocity is doubled, then maximum height will become 4 times the previous value. In that way, maximum height depends on initial velocity of projection for small region, because for small region of space this g is constant, of course. So g is constant. That's why maximum height depends on initial velocity of projection. So this is expression for maximum height in the case of body projected vertically upwards. So for body projected vertically upwards, the time of ascent is given by u by g. So time of ascent depends on initial velocity, and maximum height is given by u square by 2g. So this maximum height also depends on initial velocity of projection. So these are the two parameters for vertically projected body: time of ascent and maximum height. Similarly, freely falling body. Freely falling body. So when the body is thrown vertically upwards, it goes to a maximum height where it momentarily stops there. Then because of gravity, again it comes down like this. Because when this is projected, it goes to this height, then comes down because of the gravitational force. Here there is no other external agency which controls the motion of the body except the Earth's gravity. Because Earth pulls the body like this, Because of this Earth gravity, the body comes down with the increase of velocity. That is, acceleration is produced in this body, which is called acceleration due to gravity. Already we have discussed. Okay. Now, if you take the freely falling body, what is a freely falling body? A body which is just released or just dropped without any initial velocity is called freely falling body. So a body which is just dropped or released from certain height is called freely falling body. So if you take this freely falling body, then here, since this is just dropped, its initial velocity is 0. And as the body comes down like this, what happens to its velocity? Its velocity increases. Why? Because of the gravitational force. This gravitational force always acts downwards. It pulls downwards. Whether the body is moving like this or like this, the earth always pulls the body towards its center like this. That is why its velocity gradually increases, hence acceleration is produced. And here the acceleration is positive plus, and its value is g. From definition, the acceleration produced in the freely falling body is called acceleration due to gravity. So that is g. So A is g. Since it is coming downwards, since its velocity increases, A becomes plus, acceleration becomes positive. So A is equal to plus g. This is for freely falling body. Now here time taken for the body to reach the ground, from this height is called time of descent. So time of descent. For freely falling body you have time of descent. Time taken by the freely falling body to reach the ground is known as time of descent. That is time of descent, right? And you can write S is equal to here, this is maximum height. S is equal to h, and h is equal to, already we have derived the expression u square by 2g. In the previous case we have derived the expression for maximum height. So when the body is thrown with initial velocity u, then it reaches a maximum height of h, whose value is given by u square by 2g. So this is the displacement covered by the freely falling body. Okay. So for freely falling body, two important points are initial velocity is 0, just because it is just dropped, there is no initial velocity. A is equal to plus g. A is positive, right? So time taken by the body to reach the ground is called time of descent, and it is represented by Td, and displacement covered by the body is S is equal to h, which is u square by 2g. This is the data for freely falling body. Now you can derive the expression for time of descent using the formula, using S is equal to ut plus half at square. You can write S means h. H is equal to, since u is 0, this term goes to 0. What is remaining here? Half g. A means plus g. So g. T means Td square. But yes, what is h here? U square by 2g. U square by 2g. So u square by 2g is equal to half g Td square. And here this 2 cancels out. So Td square is equal to u square by, this g comes to denominator here, then g into g, this is g square. Then Td is equal to u by g. So time of descent is equal to u by g, where u is initial velocity of projection. That means when the body is thrown with a velocity u, then it goes to maximum height, then again it comes down to the earth. Then time of ascent is, you have u by g, and time of descent is also u by g. So time of ascent is equal to time of descent. So when the body is thrown with a certain initial velocity vertically upwards, then time of ascent in this case is equal to time of descent. So both depends on initial velocity of projection. Then time spent by the body in air, that is time of ascent plus time of descent. During this time, the body projectile will be in the air itself. Hence, time taken by the body to reach the maximum height again comes to the ground after it is projected. That is called time of flight. Time of flight means time spent by the projectile into air after it is projected is called time of flight. So, time of flight is represented by capital T. This is equal to time of ascent plus time of descent, that is u by g plus u by g. Then you get 2u by g. This is time of flight. So, time of flight is equal to 2u by g. Time of ascent plus time of descent is called time of flight. Okay. And for freely falling body, this is one term, time of descent. Another one is velocity with which it touches the ground. When the body is dropped like this, it comes to the earth surface finally. So, when it touches the ground, what is the velocity? You can also calculate. Velocity with which the body touches or reaches the ground can also be derived. So, expression for velocity when it reaches the ground, velocity when it reaches the ground. So, for this again you take this is the initial point, just dropped initial point, finally it reaches the ground, this is the final point, this is the journey. So, for this motion you can write the data like this: u is 0, a is equal to plus g, and s is equal to h, which is u square by 2g. We have to calculate or we have to find the expression for final velocity, that is velocity with which it touches the ground. So, v is equal to how much? For this you can use the formula v square minus u square equal to 2as, right? Here v we don't know, so v square minus what is u here 0, this is equal to 2, what is a here g, into s, what is s, which is nothing but maximum height, this is u square by 2g, u square by 2g. So, this 2g cancels out. So, v square equal to u square and v is equal to u numerically. Generally plus or minus we take, because this is when you taken square root, you get v is equal to plus or minus u. One is correct. Which one? Generally v is equal to minus u. If you take sign also, v is equal to minus u. Why? Here u is the velocity with which it is projected. That means initial velocity will be like this. Initial velocity direction is upwards. When the body touches the ground like this, velocity will be like this. That means when the body touches the ground, velocity will be downwards. So, if you take the initial velocity direction as positive, the final velocity with which it touches the ground is, since it is in opposite direction, it should be negative. That is why when u is positive, v should be minus. So, v is equal to minus u. But numerically if you take v is equal to u, numerically if you take v is equal to u, means when the body is thrown to certain velocity like this, then it goes to maximum height, again comes down and touches the ground with the same velocity. There is no change in its velocity. So, when it is thrown with a certain velocity, finally when it touches the ground, it touches with the same velocity. So, v is equal to u. This is an important point. So, when the body is projected vertically upwards with a certain initial velocity, then it goes to the maximum height, again comes down and touches the ground with the same velocity. So, velocity with which the projected body reaches the ground is equals to the velocity with which it is thrown initially. So V is equal to U. So this is freely falling body. So in both the cases, if you take freely falling body or body projected vertically upwards, in both the cases the body is controlled by, the body motion is controlled by the gravity, that is Earth's force. So Earth's force controls the motion of the body. That means velocity changes are produced because of the gravitational force, and this acceleration is called acceleration due to gravity. The change in velocity per second in this case is called acceleration due to gravity. So when the body is moving upwards or downwards, in both cases you take A as G. Of course there is sign convention. When the body is coming downwards like this, A is plus G. When the body is moving like this, that means when the body is moving vertically upwards, in that case A is taken as minus, that is A is equal to minus G. Moreover, for freely falling body, U is 0 and body projected vertically upwards at the maximum height, final velocity is 0. So here it comes down, this is just released, initial velocity is 0. Similarly, when the body is projected like this, it goes to maximum height. It goes to maximum height. So at this point V is 0. So for vertically projected body, final velocity is 0. A is minus G. For freely falling body, initial velocity is 0, A is equal to plus G. So these are the two changes which are generally used when we are using a kinematic equations to solve the problems for freely falling body and body projected vertically upwards. Okay. So this is motion under gravity. So this is called motion under gravity, freely falling body and body projected vertically upwards. So we have discussed time of ascent, maximum height, time of descent, velocity with which it touches the ground, and time of flight. Okay. Now you can do problems based on these parameters. So in the case of freely falling body and in the case of body projected vertically upwards, you can do several problems.